Okay, I think this is a homework problem 1271. We have a particle initially at rest. They state that by saying v is equal to 0 at t is equal to 0. They give us the acceleration as a function of time, and they say what is the position at 1 second if it initially started at 3, 2, 5 feet. This would be a position vector r0 of 3i plus 2j plus 5k. I would do that right away. And it's in feet. So since we're given the acceleration, let's start with the definition of acceleration. It's equal to the derivative of velocity with respect to time. I can separate those variables and get dv is equal to the acceleration times dt. And we're going to integrate that. Let's go ahead and plug in acceleration. We have 6t in the I, don't drop your I and j or k components, plus 12t squared in the k. We have no acceleration in the j direction. And we're going to integrate from some v is equal to 0, right there, to some v, and this side from some t is equal to 0 to some t. We're going to put 1 in, but I like doing the generic, get a generic solution. Okay, integrating, we will get velocity as a function of time equal to 3t squared in the I direction plus 4t to the third in the k direction. That is now in feet per second. So once again, don't drop these components. I do see people report answers back like this, and if they can add them, they try, but since they're different exponents or degrees, they can't add them. This is a wrong answer. It has to have components next to it. Okay, now it asked about position. We need to integrate once more to find the displacement. When we integrate, we'll get a position function of t, but that represents the displacement, if you remember, the area under our curve of v versus t, which is what we're about to do, take the integral of v dt, is actually the displacement or change in motion. So we need to take this initial position into consideration. So what I'm going to do is go ahead and start with the velocity definition. It's equal to dr dt. We can rearrange that, separate the variables, and get dr is equal to v dt. Substituting in v, I get 3t squared, don't drop the I, plus 4t to the third, don't drop the k. And we're going to integrate, and this is going to give me some final position vector, some r1 if this was some r0. And it's not, it's a displacement, right? So we need to add these two things together in a second. Okay, integrating this will give me t to the third in the I direction and t to the fourth in the k direction. I'm going to find the position, it's going to be equal to its r0 plus however much it was displaced, and we'll evaluate that at t is equal to 1 second. What I get will be some position vector r at t is equal to 1, and we'll have that t to the third plus 3, t to the third for the I component, 3 for the initial coordinate. It's in the I direction. We had no acceleration in the j direction, so we're going to hold on to that 2-foot coordinate. We just have 2 in the j. And we have a t to the 4th for our k component, and we need to add its initial position, which is 5. Alright, that gives us, when evaluating at t is equal to 1, 4 in the I direction, 2 in the j direction, and 6 in the k direction. And this is all in feet. Thank you.